Assalamualaikum and good morning everyone. Today we are going to present our engineering design slide, which is about the product design of a compact mini crane. Let me introduce myself. My name is Muhammad Amshar. My metric number is 01 DKM4C F1083. So, this project is part of our subject TJJ 40343 Engineering Design under the guidance of our lecturer, Mr. Muhammad Arif bin Hussain. Now, I will explain our project objectives. First, the main objective is to design and fabricate a mini crane model using CAD software and 3D printing technology. So this helps us to understand how digital design is transformed into a physical product. Second, we aim to practice safety procedures during the fabrication of the 3D printing and testing process. So especially when handling machines and tools. Third, we want to produce a functional prototype with a stable structure so that the crane can operate safely without tipping or failure. Lastly, this project allows us to apply the engineering design process, which includes idea generation, design, fabrication, assembly, and testing. Now, I would like to invite my friends Umar to continue with the explanation on the next part of our project.
Assalamualaikum, my name is Umar Abdul Aziz Abdul Rasid. My metric card number is 01DKM24F1069. Today, I will present about our project design, which is a mini 3D printed crane system. This presentation focuses on the design components and the manufacturing process. Firstly, I will explain about the design overview of our project. The project is a mini crane prototype that is specifically designed for lifting light objects in a controlled and efficient manner. The main objective of this design is to ensure stability, functionality, and smooth operation during lifting tasks. The system consists of several main components. First is the base platform, which provides a strong and stable foundation to support the entire structure and prevent tipping during operation. Next is the vertical support column, which acts as the main structure to hold the crane arm and transfer the load safely to the base. The third component is the crane arm, which is responsible for extending outwards to lift and move the load. This arm is connected to a rotational joint mechanism, which allows smooth and controlled rotation of the crane. These features improve flexibility and enable the crane to operate in different directions without repositioning the base. Finally, the hook or load holder is attached at the end of a crane arm, which is used to carry the load securely. From the image shown on the right, we can see the CAD design of each component, including the base, arm structure, and joint mechanism. The design was developed using CAD software to ensure accuracy and proper assembly. Overall, this compact design focuses on stability, ease of movement, and efficient lifting performance. Next, let's look at the design overview. The crane consists of several main components, which are the lower crane, rotational part, base motor, and upper crane. Starting with the lower crane, this part acts as the main support structure. From the drawing, we can see that it has a stable base with two vertical brackets. These brackets are designed with holes to allow connection using pins or screws. This ensures proper alignment and smooth movement when connected to other parts. Next is the rotational part. This component is circular in shape and placed between the base and the crane structure. Its main function is to allow rotation of the crane. The multiple holes on the top surface are designed for mounting and securing other components. This part is important because it enables directional movement of the crane. Moving to the base motor, this part supports the motor installation. The design includes a central hole for shaft placement and additional holes for mounting screws. The flat base ensures stability, while the raised section helps position the motor properly. This component plays a key role in transferring motion to the crane system. Lastly, the upper crane is the extended arm of the crane. From the drawing, we can see that it has a multiple holes along its body. These holes are used for joints and connections, allowing movement and flexibility. The angled structure helps in lifting and reaching objects effectively.
Everyone, so my topic is manufacturing process. So we have 7 process here. So first process I'm gonna explain about the sketching concept. So below you can see they have a sketching, and the meaning is it's based on the project idea, early hand sketch, and also the sketch are prepared down there you can see. So sketching concept is like something about draw initial idea based on our project concept. So what if our project concept that we need to do it by the demanding on the project concept modeling. So in this project we had used the CAD modeling for our drawing. So the meaning is CAD modeling usually create 3D design and using a Fusion 360 and check dimension. That means it will use the 360 degrees for the design. And thirdly is about the file preparation. So design need to be convert into STL file. That is that we need to do our file in a STL form. Third, we have to do the 3D printing. So 3D printing is print each component using the PLA material. Processing, so post processing is remove the support and smooth the surface. That means and clearing the surface to get a smooth finishing on our 3D printing product. Okay, so third I'm gonna talk about the assembly. So assembly is printed part assembly using screw. So testing is about rotation movement test to see the structural stability of the 3D printing product. Guys, so this is 3D printing machine handling. So before operation machine, condition need to be inspect. So whatever machine that we're gonna use, we need to check the condition to make sure there's no any error or any accident happen. So next I'm talking about the filament need to be loaded properly. So what they're trying to say is insert the filament correctly so it can be flow smoothly without any blockage during printing. So there won't be any issue during the printing, so the blockage won't happen. So next it's about bed leveling and nozzle checking are performed. So what they're trying to say is we need to adjust the bed height and ensure the nozzle and it in a correct distance for a good printing quality. And fourth, correct temperature need to be set for the PLA material. So the temperature should be balanced so that there will no any accident or maybe stringing will happen in a 3D printing during the printing process. So the next is upload the G-code file into the printer. So what is G-code? G-code is something that we need to transfer the prepared design file into the printer to start the printer process. So this is something about the starting process. So next is about start printing and monitor first layer adhesion. So what they're trying to say is begin printing and observe the first layer to ensure the process of the sticking and the enlightenment. So next is about remove printed part carefully after the cooling system. So we have to wait after we use the print because it should be cooled down and it will be safe to use for the next process. So lastly, we need to clean the nozzle after the use. So usually we have, for the long term, we have to use the printing machine, 3D printing machine. So we have to clean and make sure we need to check the maintenance properly, so that there won't be any issue will happen in a long term, and we can use it for a long way in term.
Encik Arif. My name is Tashan Kumar, anak lelaki sebelah Kumar, and my matrix number is 01 DKM 24F 1080. So now I'm going to explain about the safety practices that we applied during our project. So basically, safety is very, very important in engineering design, especially when we handling the 3D printing machines and mechanical components. Okay. First of all, uh, there are so many safety practices. So here are the some that I'm going to explain. First, we need to wear a proper PPE such as safety shoes and goggles to protect ourselves in the lab. Second, we need to avoid contact with hot or moving parts like the nozzle and heated bed because it can cause burns or injury to ourselves. And also, we always need to keep our working area clean to prevent accidents and ensure a smooth workflow and working environment. During assembly, the tools must be handled carefully, especially the sharp tools, because it can cause injuries to us. And then, in addition, we always follow our instruction by that given by lecturer or lab assistant, and switch off the machines after use. Lastly, the main important part is the teamwork. The teamwork and coordination are really important to ensure all the works are done safely and efficiently. These practices help us maintain a safe working environment throughout the project. So, in conclusion, we have successfully designed and fabricated our mini crane project successfully using CAD modeling and 3D printing technology. The rotational joint system functions smoothly, allowing controlled movement of the crane arm. The prototype achieved both structural stability and functional performance, which meet the project objective and needs. So from this project, we have gained some valuable skills in design, fabrication, machine handling, and problem solving. We have also applied few engineering design principles and safety procedures, which help us to maintain a effective work throughout the process. So in overall, this project improved our understanding of real engineering applications, especially in terms of material selection, mechanical movement, and safety consideration. So finally, we have reached our last slide of this presentation, which is about reference. So these are the reference that we used in our project. These sources we take from engineering design textbook, ergonomic design reference, and engineering design process guidelines. These reference support us to make our design decision, safety consideration, and our overall project development. That's all from us. Thank you.